API resiliency is ability of any API to constantly return expected results when they face with errors, high traffic, and or the partial system failures. This involves implementing common API resilience design patterns such as retries, timeouts, circuit breakers, failover, or fallbacks. A fallback using API Gateway is like a plan B for an API when the primary endpoint fails. The API Gateway can redirect traffic to secondary service or return a predefined response. My name is Babur. In this video, we'll explore the challenges with existing fallback techniques and how to implement resilient APIs efficiently by focusing on the fallback strategies using APISIX API Gateway. Fallbacks are a critical component of a resilient system design. However, they can introduce more problems when they are implemented incorrectly. When discussing fallback strategies, challenges faced can differ between single machine environment or distributed systems. You can face a difficulty in testing fallback logic because, for example, API on a local service has a fallback to the cached response when the actual database is unreachable. Testing this scenario requires simulating database downtime, which might not be a part of regular testing, even leading untested fallback code under actual production load. Also, fallbacks themselves can fail. Let's imagine API might have a fallback to write logs to local file system when remote logging service is unavailable. This could lead to slower performance due to synchronous issues with file input-output operations. And there are other issues also where fallbacks have some operational risks, fallbacks have latent or amplified bugs. So in this case, you need to use central solution like API management, API gateway. For example, APISIX allows for the configuration of dynamic routing, can be used to periodically redirect a portion of traffic to the fallback services. This ensures that the fallback paths are exercised regularly and remain ready for use. To implement the fallback mechanism with APISIX, you can use its built-in upstream priorities feature, where you can set up each upstream node with a certain level of priority to enable when the node endpoint with a higher priority fails, API Gateway can redirect the traffic to secondary node with a lower priority. And default priority for all nodes can be assumed as a 0, and nodes with negative priority can be configured as a backup service. Next method is using fallback with APISIX response rewrite plugin, where it allows you to modify the response status code, body, headers before returning it to the client application. This can be particularly useful for implementing fallbacks by providing a default response when the upstream service fails. Let's see next throughout the video how to implement these two fallback mechanisms with APISIX using upstream priorities and a response rewrite plugin. Here are step-by-step examples. I'm going to show how to set up both fallback methods. Some of the prerequisites to follow this video tutorial: you need to have these tools installed locally. Also, it's nice to have the basic understanding of what's APISIX and familiarity with API Gateway, which has a key concept like routes, upstreams, admin API, and plugins. And make sure that the Docker is installed on your machine because we're going to install the APISIX with all the necessary components using Docker. And also we will use curl command to send a request to the service for configuring these fallback features and validating. This demo project leverages existing predefined Docker Compose configuration. It is on GitHub. You can find the GitHub repo called APISIX Docker. The link in the video description. If you navigate to example folder, there is a Docker Compose configuration YAML file where you can set up, deploy APISIX, etcd, and Prometheus and other services with single command. First, start with cloning the Docker APISIX Docker repo on GitHub. Open it in your favorite editor, and then you can navigate to the example folder and start the project by simply running Docker Compose command in the terminal. As you can see, in my case, I'm using a Windows operating system, and I have installed Docker Desktop. After I did the Docker Compose up, all these necessary services are up and running. When you start the project, Docker downloads any images it needs to run. It also runs to example backend services, Web 1 and Web 2 accordingly. And you can see the full list of services, the same in the Docker Compose YAML file. In my case, as you can see, I'm using VS Code, and I can see the Docker Compose YAML file in my local machine. We'll start by enabling fallback mechanism with APISIX Upstream priorities. To do so, you can just open a new terminal and try to run the following curl command. I'm going to explain now this curl command one by one. We're creating a route, as you can see, by accessing the APISIX admin API that routes the request to two backend services, Web 1 and Web 2 respectively. And we configure the priority for each upstream service nodes. First, Web 1 has a priority 0, which is just default priority, and Web 2 has a negative priority, which is less than the first priority. If the node with a higher priority fails, APISIX automatically forwards the request to the route to the node with a lower priority. Another configuration in this route, we are also specifying HTTP method. This route can get matching. In this case, this match get requests. All these get requests to URI/get endpoint will be forwarded to one of these upstream nodes. Now, if I run this in my terminal, this curl command, as you can see, APISIX responds successfully, which means we created a route with two upstream nodes. We can verify now if we can get only response from Web 1, which has a higher priority. I can do request to the route/get. If I do that, as you can see, even if I request it multiple times, I'm getting only response from Web 1 service, which means Web 1 has executed first as it is working and functioning. Now, if we stop Web 1 service container from the Docker to verify if APISIX fallbacks to Web 2 service, we can stop easily by running Docker container stop with the container name of Web 1 service. After you run this command, now the container should be stopped at the Web 1 service. And if you send again another request to the route, you will get a response from fallback service we specified, which is Web 2. If you run this request, it takes usually 60 seconds while the request goes to service 1 first and fall back to the service 2 if it's unavailable. You can also change this time by setting timeout attribute of the upstream object. This fallback method also works well with upstream health checks too. As you can see, we got a response from hello Web 2 already, because Web 1 was failing, and APISIX forward request to the second service. This is how you can enable fallback with upstream priorities. The second fallback approach is with APISIX response rewrite plugin, because response rewrite plugin allows you to modify the response status code, body, headers before returning it to the client. So if you follow the first approach, we need to rerun the Web 1 service container once again because we stopped it in the previously. We just rerun it to use the response rewrite plugin for our fallback. We need to configure it again in the route. I'm going to explain this route configuration. We are creating or rewriting existing route. So with the curl command, in this example, we are defining a single backend service in this case, not like as a previously one. We created two backend services. In this case, we have single, and where the traffic should be directed to when this route is matched, when there is a get request to the /get path, and the response rewrite plugin here, as you can see, will modify response to have 200 status code if the backend service is failing with another HTTP status 503, whereas service unavailable. So response rewrite plugin will update not only the status code but also the body message by saying this is a fallback response when the service is unavailable. So you can also change this JSON body to customize this message, or even return another JSON body. So exactly this vars in condition tells the plugin to apply the rewrite only when the original status code of the response are 500. You can also specify here multiple HTTP status codes. Let's run this code command. You will get successful response, and now if you send the request to the route, you should get a modified fallback response immediately. Oops, yeah, we need to also stop once again the Docker container, because we started it over. Let's stop it once again, and to test if one is failing. It means there is no backend service now because they are not responsive. And if we send once again the request, you should get the response from the response rewrite plugin. Here we go. As you can see, we are getting the fallback response. That message we defined it in the plugin configuration. As we have seen in this video, fallbacks are safety net for when things go wrong with APIs. By using APISIX Upstream configuration or response rewrite plugin, you can provide thoughtful, user-friendly responses that keep the system functional and maintain a trust with users. Thank you for watching. If you want to learn more about APISIX, and please subscribe to our channel, click on the bell to receive notifications about new videos.